Welcome back to the Flaming Microphone. I am Dr. R. Venugopal and we continue with Dr. Chokkalingam Karapaya. Dr. Chock, Ohmium delivers everything from AC power and city water to pressurized purified hydrogen. Dr. Chock, walk us through that architecture and what does it simplify for an Indian EPC contractor or project developer?
Yeah, great to be part of the second part here. And when you look at a traditional electrolyzer project, somebody makes a stack, somebody sends the power electronics rectification of AC to DC, somebody works on water treatment, somebody works on hydrogen purification. When these are all coming from different companies, there are multiple interfaces and ownerships, boundaries. So every time there is a boundary, there's an efficiency loss, there's warranty ownership issues and other things, and there's not a single person that EPC can reach out to, right? So we understood this as one of the key needs and a differentiator that we need to bring to the world, and that's why we did this integrated system, which is comprehensive in nature, where we had the AC power coming in. That is the power conditioning unit, rectification, and the DC-DC control. And that feeds the DC power. And there's a water, city water comes in, we purify it to the purity level that the stack needs, right? And then on the other outlet side, hydrogen purification, drying, and all that is also taken care of. So the customer doesn't have to worry about these specifics. They have one phone number to call, one warranty to be discussed. So that's why we did it in this fashion. And as a result, for the EPC companies, it simplifies. Okay. So they can lay the concrete, they can lay the power and the water supply, put these units, connect, and go.
No buildings, no HVAC, rack-in-rack maintenance. And what does that actually mean for EPC cost and construction risk on a 10 to 100 megawatt project in India?
Yeah. So when you look at we talked about in the part one about the footprint.
Yes.
So the footprint coming down directly impacts the construction. And going beyond that, not needing the full building helps with minimizing the civil construction cost. And along with that is the HVAC cost. All of that is minimized. Now, in addition, the modular structure makes it that you don't need cranes. So if you build a building, then you need to put a crane on top and all of that, right, to move the equipment around. So all of that is removed, right? So when you look at, let's say, 10 to 100 megawatt project, we are from the time, let's say, the concrete is ready, the power lines are laid out, and there's a transformer already done there, and the power is coming in with 415 volt AC. The water line is laid out. From the time we land our units to producing the hydrogen, we're saying 16 to 20 weeks. That's it.
That's a great time.
Yeah.
If you are able to complete within that time, it is a unique one.
Exactly. So that's the power of this architecture.
Your data always shows that 16 to 20 weeks for installation commissioning in your Indian projects. What helps you that timeline? Where do you anticipate any delays? Whether it has happened any time?
Yeah. So early on, when you're looking at any technology, there is a learning curve and the going through that, right? So we created an internal beta structure, meaning, let's say we say there is a customer internally. We simulated, let's say we ship from our factory to the customer. What are all the things that will be happening at the customer place? We did a role play. So we created and then tested it in the manufacturing, went to the quote unquote on the other side, and then called it the field, right?
Oh, great.
So that helped us understand where are the gaps.
Where are the lacunas?
So that helped improve the manufacturing inline testing.
Okay.
So we do the subsystem testing of every subsystem, And as a result, when we ship out these units, they're already pre-tested.
Oh, great.
So there's no surprise at the site for testing from a testing
So
point
a
of view.
mock installation will be done.
Right, yes,
Right.
because everything is going through the testing.
Oh, great.
Yeah.
That's nice.
Yeah.
Your Bangalore Gigafactory is now at 2 GW.
Correct.
Certified to ISO 9001, 14001 and 45001.
Yeah.
How does having everything under one roof change the cost and quality of your customers?
Yeah, this is such a critical thing for a new technology that's coming up, right? When you're coming up with new technology, there are lot of moving pieces. The supply chain is not established, right? So you have to develop processes there and then ensure that the performance is met. And there's obviously a margin that's added in each of the components. When you do the vertical integration of the core components, be it the stack components, right? One, you understand the true cost structure of it. And you are able to tweak the performance parameters of these components to make it more efficient, to last longer. So that tunability is provided by this vertical integration. So, and I touched on the manufacturing testing, right? When you do all of this, you are able to test even at the component level what you expect in the full stack level.
Okay.
So you are able to do production sampling testing and then take actions and don't wait till you build the stack. So if, for example, let's say one critical component for stack is coming from a supplier, there is not that close coupling. So by the time we find out, there's already a lot of inventory that the supplier had produced.
Yes.
So by having this close coupling, your time to react in case of any process drifts is much faster.
Absolutely.
So this provides performance and quality and safety as well for our customers, this integrated approach.
So there will be a third-party inspection at each stage?
So the third-party inspection is done during the UL certification, for example, CE certification. So when they come in, they certify it. As part of our UL certification, there's called manufacturing line inspection periodically. So they will come in and then verify the processes and is there a delta DFMEA, PFMEA done for the process changes that are happening. And then there's a complete traceability of all the units. CE requires for critical one, like SMPV rules and other things, right? Even the iron lot, right? The steel lot number to be traced all the way back. So that's how we are managed.
So your quality control is assured in every stage of
the
manufacturing
process.
till it reaches the customer side.
Correct.
Right. You have India's largest PEM order, 400 megawatts with the National Thermal Power Corporation, and partnership with the Tata projects, as you said, CSIR, CECRI, and I heard that it is with the IIT Madras also.
Yeah.
How are these Indian collaboration actually shaping your product?
Yeah. So let me touch on the projects first, and then we'll go into the R&D. On the project side, at the end of the day, this has to meet the rubber has to meet the road.
Yes,
right?
absolutely.
And that comes from the projects. And we cannot be all things to all people. So we need this extended enterprise where the projects developers like NTPC, like Tata Projects, like Hero Future Energies. These are all the people who are working with the customers. And then we become the OEM supplier for them. So this helps us expand our reach rather than being marketing and sales directly to the customer. So we go through these project companies, and that's tremendously helpful. NTPC, Tata Projects, Hero Future Energies, these are all great project partners that they're evaluating e-methanol projects, ammonia projects, refineries, all these. They're able to go present. And one of the recent projects that we just announced, I think it will become the second or the third largest project in India in green hydrogen, is the NLC project, 4 megawatt with Insolar. Insolar is another project developer company.
Absolutely.
So we are working with them, and very innovative company, and we are very glad to partner with them as well.
What about the R&D, research and development?
Yes. So when you're talking about the roadmap, so when I touched on my role at Ohmium, it's both the near term as well as the longer term, right? There's a 3-horizon approach, right? Near term, medium term, and longer term. As part of the 3-horizon approach, we are working on the current horizon within the 4 walls of Ohmium. But the medium term and longer term, where the materials come into play, what are there alternate catalysts? Are there alternate materials? CECRI has been doing this since 1957.
Yes.
It makes
sense.
Exactly. So that's why we collaborate. And
what about
same
your
thing with
IIT Madras?
IIT Madras Research Park? It's very innovative, right? Lots of startup type work, like lots of startup collaborations, and with professors on the various other aspects. One example I can give is we were talking to some experts from the ocean about the offshore deployment.
Yes.
So how do we structurally build the units so that it can go through the wave, tidal energy and all that?
That's a great.
Yeah.
So in different field of this applications you are working on.
Exactly.
Research are going on.
Correct.
For Indian startups and component manufacturers, so many people will be listening.
Yes.
Where is the real opportunity to plug into Ohmium's value chain?
Yeah. There are multiple opportunities.
Great.
That's a great thing, right? So,
because so many startups are come in India.
Yes.
So they will be looking for your value chain.
Yeah. Let me go zoom in from outside in, right? So when you talk at the large level, you're looking at the balance of plant components, right? Be it pumps, sensors, actuators, sheet metals, all of these, right? All of that material, balance of plant components. Power electronics side, tremendous opportunity, right? And interestingly, when you look at the power electronics, it's not just about green hydrogen. When this power electronics can be for the electric vehicle chargers, similar power electronic architecture. So it's for solar inverters. So it's a larger system that you can actually come and play. And this is something that we are definitely, when you look at the devices and modules for these power electronics, they are all coming in from outside. So as India is looking into the semiconductor improvement, in addition to looking at the GPUs that are needed for AI, they should also be looking at the power side of things.
So power electronics, dispensing, right? Storage tanks.
Yeah,
I said already. Composite cylinders.
So these, plus I would say longer term, think about some new membrane.
Yes.
Why not?
Great.
We don't have to depend on external world for membrane. We can create it ourselves here.
So startup people, please listen to Dr. Chock's innovative methods you can look into. Dr. Chock, your systems comply with ISO 22734-1, ANSI B22734 and NFPA 2.
Yes.
That is the main code which we use. With the deployments from desert heat to sub-zero cold, what are the top 3 safety lessons Indian regulators must internalize before approving large-scale green hydrogen projects?
Yeah, this is excellent. Definitely very, very pertinent to what's happening. So when you look at the safety standards that are being looked into, the NFPA is specifically based on hydrogen properties and other things. When you're looking at the heavy hydrocarbon-based easement planning, then you're missing the point on the cap. So sometimes you get over-engineering in terms of the space, and you miss out on the critical safety needs for the hydrogen case. Hydrogen is a great dispersant, right? It diffuses, whereas heavy hydrocarbons stays in one place. So understanding this and then ensuring that the safety aspect is designed based on the physics of that hydrogen molecule. That's one. Number two, I would say look at it as not as a cost-only approach, right? Mm-hmm. So don't go for the most cheap one and then later you have to put in systems control to take care of the safety. So we touched on the transients, yes. Right? So the transients is very important for avoiding this gas mixing thing. And these are important from the startup and shutdown. These are the times when you go through this LHL crossing that, lower LEL crossing that level, right? So when you have this least expensive one, you may compromise on safety. So you have to be very, very careful.
That's a very good, valid point.
Yeah.
Because in India, most of the project L1,
right,
that is the criteria which is being used.
Correct.
Here is the importance of good quality products.
Exactly.
Are there parts of current codes you find too conservative or not strict enough, particularly on outdoor siting, venting, or hazardous area classification?
Yeah. So I touched briefly in the earlier discussion. I think if we can look at the specifics of NFPA 2 and then looking at that and applying it for the siting distance requirements and not using the LPG-based approach, right? So the LPG has a different characteristics. So that I would say we are very conservative in India right now.
Absolutely.
I think we can be tune that and then fix that gap. On the stricter side, I would say in a mixed situation, when let's take, for example, oil refinery. You have hydrogen coming from gray source.
Absolutely.
You have hydrogen coming from the green source. And the carbon intensity definition and how that is mixed and other things, that's not very clearly defined. I think it can be clearly defined and made it stricter. There's some initial thoughts on from MNRE on the GHCI, green hydrogen carbon intensity requirement. And as part of that, it can be added. There are lots of commentary. It's, I think, going through a commentary period. I think it can be accelerated. I think that will be good.
Oh, great.
Yeah.
That's a great point.
Yeah.
From feed and HACCP experience, what are the most common mistake first-time green hydrogen developers make in India, and how can we avoid repeating them?
Yeah, there's some overlap. One is certainly the L1 methodology. I think I can understand where we came from, right, across the board, different industries. The L1 we were price sensitive market for a long time. But in a technology that's performance critical, safety critical, we need to look at the total levelized cost of hydrogen approach.
Absolutely.
So when you look at that rather than the first cost, that's one of the key things that I can say is needed so that it's not only from the initial performance, not only from the life, but also from the safety. So I would say that. Number two, I briefly touched on it on my transition from fuel cell to the electrolyzer. One thing I want the entire ecosystem of electrolyzers in India to be very mindful of is the water quality. So the water quality can lead to not just the initial performance, but also if there is some internal degradation mechanisms that happen in the membrane could lead to some safety incidents. Number three, please look at what's the HACCP. Please do a detailed HACCP of the startup and shutdown.
Absolutely.
Right. So there is one recent incident that happened in UK. There is this company CPH2. I think it's called CPH2. They did an operational update where there is a shutdown sequence, which led to mixed gas scenario, and they provided that update to the London Stock Exchange about this. So we'll have to be very careful on the startup and shutdown sequence and avoid this mixed gas situation.
Ohmium products are getting bigger, more efficient, and more reliable with each generation, from Mark 2.5 to Mark 3 to Mark 4. In simple terms, what is making that progress possible?
Yeah. When you're looking at the efficiency improvement, it relates to the resistances of the internal components. In fact, I sometimes explain the word ohmium comes from reducing ohm, which is the symbol for resistance.
Yes.
We are always studying to make the resistance lower and lower and lower so that we can make that efficient. Yes. So it goes to making the layers optimized, thinner membrane. When you go to thinner membrane, the issue that I just talked about, we want to make sure that there's no gas crossover. So we ensure that. So that's one of the aspects as we look to future improvements of efficiency and performance. On the life side, we look at the specific failure modes of each of the components at the microstructure level, and then we design that out. So that's how we improve the life. And these are all beneficial from our hypermodular architecture. For example, I always give an example of this social media sites, right? Facebook, LinkedIn. At any point, there are 20 different versions running, and these companies are doing A/B testing on what sticks and what doesn't of the different product features. How do you do that in a product? Our hypermodular architecture comes into play.
Okay.
So we are able to say, for example, Mark 2 is being developed internally, or Mark 3 is being developed internally. In field, we have Mark 2, Mark 1. So we can actually ship Mark 2 stack and then go put it into Mark 1. It's backward compatible.
Okay.
And that helps with the customer in the efficiency. And we get the data.
Oh, that's a nice.
So we can actually do that, and without impacting the customer satisfaction issues.
So what's the difference in the Mark 2.5, Mark 3, Mark 4?
Yeah, so we have a central rule that you can change whatever you want as long as it fits within that cabinet.
Okay.
So we change a lot of things within the stack, but it should still fit within that cabinet.
Looking into 2030, what would success look for Ohmium and for India's green hydrogen ecosystem as a whole?
Yeah. So you started off the podcast of the part 1 with the vision that India has. I think that's tremendous. I think in addition to the vision, the federal or central government is certainly putting in the policies like avoiding the wheeling charges for green hydrogen, all that. These are all very good. And so when I see, even if we don't exactly meet that vision of the 30 million metric ton, if there are 50 to 100 projects that are delivered, that will be amazing.
Yes.
Right. So number 2, for Ohmium, I think it's getting to that levelized cost of hydrogen.
Yes.
To the grey hydrogen parity. How close can we get to? If we can get to 200 to 250 rupees per kilogram, yes.
That is the biggest achievement.
Exactly.
We are waiting for that.
Correct. Yeah.
What is the single mindset shift you would ask for Indian engineers, startup founders, and regulators so India lead in green hydrogen, not just adopt it?
So really, mindset shift, I would say, is technology adopter versus technology developer.
Yes.
Okay. So for a long time, for the right reasons, we as a country, except in mission critical ones like defense, we had procured ready-made technology, executed operationally very well on the manufacturing side. Right? We are great executioners on the manufacturing side, but when it comes to the product development, we have to shift that mindset. So technology adopter to technology developer.
Okay.
That's what I would say as a single mindset shift.
I would like to ask you some rapid fire questions.
Sure.
You can answer in one word or one sentence.
Okay.
One word for green hydrogen current status in India.
Growing.
The most underrated application of green hydrogen in India today.
Most underrated. E-methanol.
E-methanol. A scientist or engineer who inspired you.
Jim McElroy, he was one of the pioneers in fuel cell development at GE. He was my mentor at Plug Power and Bloom Energy, and we owe our success to them. So Jim McElroy.
One regulatory gap you would fix overnight in India's hydrogen ecosystem.
It's that first point I talked about. Understand the chemistry and physics of hydrogen and fix the easement gap needed so that it can meet that. I know it's not a single word, but I would say NFPA to adherence.
Okay, great.
Yeah.
The year PEM achieves cost parity with the grey hydrogen.
I would like to say 2030.
2030?
Yeah.
Oh, great.
Yeah.
That's when.
Yeah.
Hope all of us will be hoping for that.
Yeah.
Your message in one sentence to young Indian electrochemical engineers or the engineers.
Initiative and ownership.
Initiative and
ownership
is Dr. Chock's advice, a message to young Indian engineers. Dr. Chock, thank you very much. In one conversation, you have given our audience a clear-eyed view of where PEM technology stands, what the honest cost drivers are, and what it will actually take to make green hydrogen bankable at scale. From reducing iridium usage 40-fold at Los Alamos to anchoring a Gigafactory in Bengaluru and signing India's largest PEM deal, your career is proof that deep science and real-world scales are not in conflict. They are the same journey. Your message is simple and urgent. India must not only adopt these technologies, it must lead in developing and standardizing them. That means proactive safety frameworks, internationally harmonized codes, and an engineering community that engage with global standard bodies rather than waiting for them to arrive. From my own experience at PESO licensing India's first hydrogen dispensing station, I know exactly how much regulatory groundwork still lies ahead and how critical it is to get it right early. The pieces are in place: abundant solar and wind, a strong engineering workforce, improving policy, and companies like Ohmium manufacturing here at world scale. What needed now is the will to execute at the speed the climate demands. If this conversation opened one new door of understanding, please share it with a colleague or an engineer or a regulator or a researcher who needs to hear it. This has been the Flaming Microphone, conversations with those who built industries, shaped India's policies, and are shaping the nation's tomorrow. Until the next spark, keep the fire burning. Thank you, ladies and gentlemen. Thank you very much. Thank you, Dr. Chock.
Thank you, Dr. Venugopal. It's been a pleasure.